Okay, fifth years. I wanted to run through a couple of example questions for you today, based around the work that you guys did on cubic functions. We've got this section and the exponential functions section to do before we have this chapter fully complete. So I would expect you to continue to get a few bits done on this between now and next week, and then we will have that functions chapter completely finished for when you guys come back in the new school year. So I'm on page 168, 169, your textbook. I'm going to run through question 2 and question 3 just to make sure that we're clear on what's happening. So we can see in these ones, in the first ones in question 2, A, B and C, the graphs are given to us, so we don't have to draw any graphs, we just have to use it to answer the problem. So you can see in the first one here, it says, using the graph above, estimate the values of x for which the f of x is equal to 0. So I want to know where that function is equal to 0. So where the y value is 0 on the graph. Okay, where the y value is 0. So all I got to do is find where the function, the fx function, hits the y-axis. Okay, so when the function is equal to 0, it means that the y value is 0. So it is at 0 here, here, and here. Okay, because that's where fx is equal to 0. X is equal to 0 at the origin, but the function hits the x-axis at this point, and this point. So we have 3 values for x where the function is equal to 0. So those values are x is equal to -1, 0, and 3. Okay, and you can see that that's the values, -1, 0, and 3 on the x-axis. So that's our x values where the function is equal to 0. The next one, it says the values of x for where the function is equal to -3. So whereabouts is the function equal to -3? I want to know where on the x-axis the function is equal to -3. So I find -3 on the y-axis. I draw across in a straight line till it hits the function. So to there, and then we can go straight up from there. And again, you'll obviously be doing it with a ruler if you have it drawn, or you can use your ruler on your textbook to do it. And I'm going to say that that one is equal to, x is equal to -1.5. But the function also hits -3 there and there. So again, I draw a straight line up from here as best I can without a ruler. And that's going to be, what, say 1.75, 1.8 maybe. And then here, again, as straight as you can. It's going to be tricky, but, and that's about 2.75, I would guess. So that's the x values where the function is equal to -3, because the function is equal to -3 all the way along that line. And then finally, part 3, it asks for the range of values of x for where the function is decreasing. Right, so I'm going to get clear all of this stuff. Sorry. I'm going to clear this stuff off this, and then we're going to go on this again. So the range of values, okay, so we're going to have a range, so we're going to have x is less than or greater than or so on for where the function is decreasing. So where is the function decreasing? That's what we have to figure out. So the function is increasing when it's going up and decreasing when it's going down, very simply, okay? So the function is decreasing from here, from here to here, essentially, all right? They're called the turning points, and we'll look at that in more detail later down the line. But the function is moving in a downward motion. The slope of the graph is negative from the point up there to the point down there. So I want to know the range of values for x between that point and that point. So what are my x values between there and there? That's all I'm looking for. And again, I go back to my x-axis, I draw a straight line, and I see the x values from here to here are the ones that are decreasing. Okay, so you can say what that's maybe, I'd say that's maybe minus 0.6, let's say. So I can say minus 0.6 is less than or equal to x, and x is less than or equal to maybe 1.8, something like that. Maybe 1.9 even. Let's say 1.8, let's say. Okay, so that's what's expected. Again, pause, rewind, go back, look over it again if you need to. The next one's here. I'm going to go through them a little bit quicker because we've done the full explanation earlier on. So part 1, it asks for the values of x for where the function or the f of x is equal to 0. So it's the 3 points where the function, the red line, hits the x-axis. So it hits it there, there, and there. So our x values where the function is equal to 0 are minus 2, minus 1.5, and 2. And for part 2, there's actually a typo. You can see that I've scratched it out there. It said the values of x for where the f of x is equal to 3, but it should actually be minus 3, because you can't see 3 on this graph on the y-axis. So you're looking for whereabouts is the function equal to minus 3. Okay, so the function is equal to minus 3 here, that point, that point, and that point, that all lie on the line y, or f of x is equal to minus 3. Okay, so all we got to do is find the x values for those. So we just draw a straight line up from where I've made the mark, like that, there, and there. Now again, not perfect. Maybe that one needs to be moved a little bit. But as you know, you'll be using a ruler and you're going to do it much more accurately than this. So that's going to be minus 2.6, say. That one straight up will be minus 0.7, let's say, something like that. And the final one will be 1.75. Remember, these are all x is equal to, yeah. And then finally, the last bit, the question asks for the values and the range of values for x where the function is again decreasing. So I know that the function is decreasing from here, from that point down to that point. Okay, so all I got to do again, get my point there and my point there, and again straight our lines, you'll get that that'll be 1 minus 1.75 is less than or equal to x, and x is less than or equal to 0.75. So x is decreasing between that value and that value, between that value and that value. Part C, same idea, exactly the same. Okay, and the question asks the values of x for which the f of x is equal to 0. So where is the function equal to 0, i.e. where does it cross the x-axis? So across the x-axis only at 2 points here, that one and that one. Okay, so I can say that x is equal to minus 1.5 or 2 in this case. Part 2, it's asking for the values of x for which the f of x is equal to minus 3. So where is the function equal to minus 3? Now again, this is the same problem. There's another typo. They've just mixed them around. That should be equal to 3 because there's no minus 3 on the graph. Okay? So the function is equal to 3 all the way along that line. That's where the f of x is equal to 3. So it's equal to 3 there, there, and there, where you hit the red line. So you bring it down in a straight line if you can, as accurately as possible, as we know, using a ruler, unlike me, and we get 3 x values. So they would be x is equal to minus 1.25, 0.75, and 2.75, if we're being very accurate about it with the straight lines using our ruler. And then again, the values of x for where the function is decreasing. So where is the function decreasing? It is decreasing between the turning points there and there. So I need to get my x value at that point. And at that point it's easy because it's on the x-axis already. So I am saying that that's going to be what? Minus 0.4, say. Let's do it again just to make sure we're clear. Yeah, it's before that, so it's about it's a little before the line, isn't it? So it's going to be minus 0.4. So I can say for part 3 that minus 0.4 is less than or equal to x, and x is less than or equal to 2, because that's right on the x-axis. That's perfect. Okay, so that's how to interpret these graphs when they're not given to you.